the derivative of the function x squared, and we're going to use the definition of the derivative, okay? So the definition of the derivative is the limit as h goes to 0 of the difference quotient. And the difference quotient is f of x plus h minus f of x all over h, okay? We all have that memorized. That is the definition of the derivative, and we'll be using it to find the shortcuts for the derivatives. So when you do this, and especially on the AP exam, don't forget to write the limit as h goes to 0 every time you rewrite the problem, okay? Or you will lose points, okay? It's important. You keep writing the limit as h goes to 0 until you actually resolve the limit. Okay, and we don't do that to the end. And I'm going to stack this. Let me move this underneath, and let's go ahead and finish this difference quotient. Okay, so what is this? The f of x plus h is take x plus h, the input, and square it. And f of x is just, the input is x now, and square it. And this is all over h. Okay? All right, so now again, I'm continuing on, and I have to keep rewriting this limit, and I can copy and paste. It's one of the advantages of the iPad. All right, so let's expand the binomial x plus h, right? X plus h squared. It's the square of the first. You can FOIL it, but here's our shortcut. Plus 2 times the first times the second, xh, 2xh. Plus the square of the last, which is h squared. And don't forget, minus x squared. And this whole thing is over h. All right, it's cleanup time. And this happens whenever you use the difference quotient. Things are going to go away. All right? The x squared and the negative x squared cancel out. This is a reoccurring theme when you have a polynomial and you are running it through the difference quotient to find its derivative. The reoccurring theme is that you're going to have this canceling out of the lead term. Okay, so let's keep going. And we end up with, let's see if I can paste back that limit. There we go. And what do we have now? On top, we have 2xh plus h squared over h. And I want to do some canceling out, but I can't cancel out until I factor the numerator and denominator. Of course, there's no factoring of the denominator, right? It's just h. So let's go down to our next line. Let me paste on my limit. There we go. And draw my bar here. In the numerator, I can factor out an h. And it's h times 2x plus h. Okay, so I factored an h out of that binomial, and then I have an h on the bottom. And now the numerator and the denominator are both products of facts. So you can cancel out. You can cancel out facts, you may not cancel out terms, right? So these are multiplied, so I can cancel out the h's, and what I end up with is the limit as h goes to 0 of 2x plus h. Now h is going to 0. Now we're going to resolve the limit. H goes away, right? And it's 2x, which means that the derivative of f of x be equal to x squared is actually 2x. And you may have learned a shortcut, but now you know how to find the derivative using the definition of the derivative, which is the limit as h goes to 0 of the difference quotient.